In this video, we're going to introduce the concept of the quotient rule. This rule is very important when it comes to derivatives because it allows us to take the derivative of a quotient, a division of two functions. So if you have a function divided by another function, like we see here in this example, that's a situation where you're going to need the quotient rule. Now, sometimes we can actually get around using the quotient rule using the product rule by rewriting it. So it's also something to consider, and I'm going to show you some examples of that as we go through more examples of derivatives. But for this question here, the best route to take is the quotient rule for now. So that's what we're going to do. First of all, what does the quotient rule say? If you want to take the derivative of a quotient of two functions, remember u and v each represent a function of x. The quotient rule says, I'm going to go to the last one here because I think it's easiest to understand. The derivative of u, that's the top. So the derivative of the top times the bottom minus. That minus sign means this order is very important. You have to do the derivative of the top times the bottom, then minus the original top times the derivative of the bottom. This order on top is very, very important. If you mix up the order on top, you will get the wrong sign for your answer, or maybe something worse, but at the very least, the wrong sign. On the bottom, you simply square the original bottom. No derivative there, just square the original denominator. So let's give that a shot here. We want to find the derivative of this quotient. So always the top I call u, and the bottom I call v. So let's organize our thoughts just like we did on the product rule. We're going to write down u, so that's t squared minus 1. Notice we're using t instead of x here. Still a variable, so it still works the same. And v is t cubed plus 1. To do our derivative of the quotient, the rule says we need to know what u prime, or the derivative of u, is. So what is the derivative of t squared? Well, pretend it's x squared. It's the power rule. Power rule says power comes down, 1 power less, so 2t. And then this negative 1 here, that's just a constant. What's the derivative of a constant? It's gone. So there's your u prime. That's your derivative, 2t. V prime, or the derivative of v, the derivative of t cubed. What rule do you need? Power rule again. Power comes down, 1 power less, so 3t squared. The 1 is a constant, so when you take the derivative, it's gone. So this is everything you need to plug in to the quotient rule. So let's write down the rule. So the derivative of y, you can write y or dy dt because there's no x here. So let me write that just so you see it. So this is dy, the derivative of y with respect to its variable t, not dx. All right, so the derivative of a quotient, the derivative of the top times the bottom minus the original top times the derivative of the bottom. All of this over the bottom squared. All we do is plug in everything in our box over here on the right. So u prime was 2t times the v, t cubed plus 1, minus u, that's the original u, t squared minus 1, times v prime, which is 3t squared. Now on top, I'm just going to label so you can see where everything came from. So this is u prime. Here's our v. We have our u, and then our v prime. Notice they're all different because they're all supposed to be different. So we're good to go up there, and then divide that by the original, the v squared. So v was t cubed plus 1. Put it in parentheses because you have to square the whole thing. All right. Technically, the derivative is done. This is the derivative, but it's very messy. So I would like for you to try and simplify at least a little bit. So what do you see that you can simplify here? Think algebra. How can we use algebra to simplify this? Some of you might be saying, oh, well, I can cancel a t cubed plus 1 with t cubed plus 1. No, because this term over here doesn't have 1. So you cannot reduce like that. To be very careful that you do correct algebra. The best option that I see right now is to distribute the 2t to the parentheses and distribute the 3t squared as well as this negative sign to the parentheses. So let's start with 2t. So 2t times t cubed would be t to the 4th plus 2t times 1, 2t. All right, now be careful here. There's a couple ways we can do this. We can do this negative sign and 3t squared separately, or we could do the negative 3t squared all together. So if I merge these together, this is really what we're distributing to the parenthesis. So negative 3t squared times t squared, that'd be negative 3t to the fourth. Negative 3t squared times a negative 1 would be a positive 3t squared. All of this is divided by t cubed plus 1 parentheses squared. So, did that help? Yeah. You can actually go even further because you have common factor or common terms, like terms. Both of these are t to the fourth, so we can put those together. So that would give us 2 minus 3, so negative 1 or negative t to the fourth. I'm going to put it in descending order, so plus 3t squared plus 2t. All of this over t cubed plus 1 parentheses squared. This is where I would stop. You could try and factor the top. There's a common factor there. But once you take the t out, the common factor, there's not anything else that we can factor. Technically, you should try, but I can see that we're going to have t cubed, and we don't know how to factor t cubed with only 3 terms. So that's not where we would stop on that problem. So half the battle is knowing where to stop. So if this is a multiple choice question on an exam, make sure you keep going back and checking. Always check your work because they're going to put on there the most obvious mistakes. So make sure you're careful. But if you see your answer, say, okay, am I done? They're not going to put different levels of simplification. So once you see your answer, as long as you did it right and didn't make one of the mistakes, you should be good to go. Let me show you another one. Find the derivative of y equals, wow, look at that mess. Does that look like fun? All right, so when you look at this, you should see, there's a quotient. But then you should stop and ask yourself, do I have to use the quotient rule here? So I showed you one where quotient rule was really the only option we had. Well, there are other options, but I don't think anybody wants to do long division, and I don't think you want to, well, we don't know how to do something called the chain rule yet. Later on, we'll have other options for the one we just looked at. But for this one, I want you to stop and ask yourself, does this look like a good thing to use a quotient rule on? Well, I would say no. The format it's in right now, you have a product rule and a quotient rule. We don't know how to do 2 rules at once when you're combining those rules together, at least not yet. We'll learn how to do that later. Right now, it needs to be either product rule or quotient rule. So what are we going to do? We got to get rid of one of them. Well, I can't divide because the product is happening before the division, or the product rule is inside the division. So let's try and work out this product first. Let's do some algebra. So on top, if we were to do the algebra and multiply, multiply it or FOIL, either way you want to look at it. Let's see what we get on top. All right, so we're going to leave the bottom alone for now. We might still need to do a quotient rule, but we're at least going to try and get rid of the product rule. All right, FOIL. Distribute the x, distribute the negative 1, and combine like terms if there are any. So x times x squared, so x cubed, minus 2x squared. Then the negative 1 distributes to negative 1x squared and positive 2x. Hey, I got like terms in there, so I can combine my like terms together. So I'm still continuing the algebra here. So y equals, notice I'm not writing y prime. This is all algebra. I'm not doing any derivative work here. So we have x cubed minus 2 minus 1, so that's minus 3x squared plus 2x. All right. Are we ready? Do we want to do quotient rule? Before you do quotient rule, ask yourself if there's any more algebra you can do to simplify. So, question, do you see any algebra here? Well, if I look at this, I see every single term has something in common. So we could reduce this by what's in common. Another thing I see is that every single term on top is over x to the fourth. So I could break this up and have, instead of one big quotient, 3 smaller quotients. Which way you go is up to you. Both directions will get you somewhere. But I think breaking it up is a good thing to remind you it's possible to do. So remember, when you have the sum and difference on top, you can break up the fraction. Each one is going to have the same denominator. So we're basically doing the opposite of what we've always taught you. We're breaking up the LCD into each individual fraction. Why is this a good direction to go? Does anybody see the benefits here? We can simplify a whole lot further. Reduce x cubed and x to the fourth. Well, we can cancel x to the third from each of these. We would be left with x to the 1 in the denominator. So that's 1 over x. That's simplified a lot. The second term, we have x squared. We can cancel 2 of them from the denominator. So we'd have minus 3 over x squared. In the last one, we would have, well, we can cancel 1x from up top and 1x from down below. So we would have plus 2 over x to the third. I still haven't done the derivative. We're still doing algebra. But look at each of these individual terms is just a number divided by x to a power. We are almost at the easiest possible rule, everybody's favorite rule. What rule is that? We're almost at the power rule. Can we rewrite this to make the power rule work? Bring all the x's up to the numerator. So 1 over x, we've talked about that one in previous videos. That becomes x to the negative 1. Minus 3, bring the x up. X squared becomes x to the negative 2. Plus 2, x to the negative 3. This is not the derivative. But now we're in a beautiful format for taking the derivative. So let's do it. So y prime or dy dx, either way you want to write it, we're just using power rule. Could I have done quotient rule? Absolutely. But this is avoiding quotient rule. Quotient rule is a very common area to make mistakes on. So if you can avoid it, it's usually a good thing. However, if you're not great at the algebra here, it might be better to try the quotient rule. All right, so the derivative. So of x to the negative 1, using the power rule. So negative 1 comes down, x to 1 power less, so negative 2. Minus 3, that's a constant multiple, so he hangs out, times the derivative of the x to the negative 2. Power rule. Power comes down, x to 1 power less would be negative 3. Plus this 2, constant multiple, he hangs out. Take the derivative of x to the negative 3. Power rule. Negative 3 comes down, and then we have 1 power less. That's negative 4. So let's just clean it up a little bit. X to the negative 2, that would be negative 3 and negative 2 multiplied to be positive 6. X to the negative 3. Positive 2 and negative 3 become negative 6. X to the negative 4. If you want to rewrite this with positive exponents, that's absolutely fine. My lab, you'll have to check and see how they ask you to write your answer. Do they want everything in positive exponents? So let's do that just in case. So if we bring x downstairs, x squared, who's left upstairs? Placeholder 1. The 6, he does not have a negative exponent, so the 6 stays upstairs, only the x moves downstairs. Minus, again, the 6 does not have a negative exponent, so he stays in the numerator. X to the 4th moves downstairs. There you go. So that's an example where we had to use the quotient rule. That was an example where we could have used the quotient rule, but by using algebra, we were able to avoid it. So quotient rule is useful, but it's also something that occasionally you're going to want to avoid to use. Instead, use algebra and use the more basic derivative rules. All right. I got more coming for you, so watch the next video where you're going to see examples where you have to figure out what rule to apply.